Science is facing a pivotal moment in the current climate. Science is under attack from fascist governments. Distrust is being seeded by both the far right and the far left. Trust in science is decreasing with a political bent to it. Publishing is under strain and it's straining from multiple different pressures. The peer review system is completely broken. And in addition to all of this, academia itself has fostered a very damaging culture that really feeds into these problems that are external to the system. But you don't have to take my word for it. We're going to go through some of that evidence today. And what I really want to do is try and make the case that for these problems, preprints currently represent potentially the best method to combating these things and the best way forward for certainly the life sciences in academia. So I'm going to highlight that preprints are the gateway to improving culture in academia, trust in research, and scientific publishing. Let's start with trust in research. I said there was a declining level of trust. This is data from the US, although it seems to be quite true across the world. Trust is still very high. I think that's really important to highlight. It's not that trust is at any kind of critical levels, but it is decreasing. The COVID-19 pandemic had a big role in that, and this is also wrapped up in a lot of the politics that are going on in the world at the moment. We have a huge seeding of disinformation from politicians, particularly on the right of politics. There's also the social media effect here, and a lot of the influencers are actually on the right of politics. There don't seem to be many good left-leaning accounts. And again, a lot of this is feeding into sort of disinformation, particularly around science. And this is why, as you can see here, we get a bigger decrease within those who lean right, because that's the kind of information that they're being exposed to. This isn't just a science academia problem. Institutions of all kinds are currently experiencing a fairly significant drop in trust. Politics is obviously the really good example. But we kind of create this problem ourselves a little bit in science, because there's a lot of things we do that decrease trust, and it's got nothing to do with these external influences. The Circosphere scandal was a very big scandal that happened during the COVID pandemic. I would suggest going away and reading more about it, but basically there were two very high profile papers published in very influential journals, and ultimately it was found that the data used for those two papers was fabricated and they were retracted. As with a lot of data that's been fabricated, certain people and actors will, despite the retraction, still jump on these studies and use them to further their own views. The other thing that we have are, if you've been keeping up with the news, you'll know, the field of Alzheimer's research has had a bit of a crisis, I would say, over the past couple of years, where it was found that a large number of Alzheimer's papers, largely from one person, one lab, have been found to have a lot of fabrication within them, and it's potentially had huge impact on that field and led to a lot of wasted effort and wasted funding. And this bottom one here is just a really good case of why we seem to be doing this to ourselves, of how we seem to be doing it to ourselves. There is that I've not linked here. There is a Nature paper, so Nature, one of the top journals you can publish in, and it was a paper about stem cells, and it took 22 years before it was retracted. Now, importantly, people within that field knew this paper was not trustworthy, they knew it had problems, but the paper was still up. So if you were not within that field, if that wasn't your area of expertise, you wouldn't really necessarily know that paper was problematic. And a large part of this trust is because of scientific publishing and how it currently works. It's currently experiencing a huge strain. Some of that is from the peer review system, but a large reason for the strain is actually shown in these two graphs. So graph A here is showing you the total number of articles published per year, and it's plotting that against the number of PhDs awarded per year. And what it's showing you is that whilst the number of PhDs awarded has actually started to decrease, the number of articles is just continuing to increase every single year. This will tie into the academic culture part that we're getting onto. And what's really funny about this is that about 100 years ago, you could find people in science complaining that there was too much literature. It was too hard to keep on top of the literature. It would be interesting to see what they think about 3 million papers per year. And on the right, this graph is showing you a little bit more as to why this is happening. And what I mean by that is if you look at those publishers that are really growing quite exponentially, so MDPI is a prime example here, although Frontiers is also following a similar trend just a little bit later. We'll focus on MDPI here. That is fairly recognized now as a predatory publisher generally. And so what's happened here with this growth is this is basically the gold APC open access model. This is where authors pay publishers anywhere from a few $1,000s up to $12,000 per paper they publish. And what this does is it creates an incentive for the publishers to publish as many papers as they can. And because publishers own all the systems within academia, and academia is so tied into the publishing system, this then directly feeds back to how researchers are judged and assessed. And so researchers themselves need to publish more papers, and it's a vicious cycle. So trust in research and scientific publishing are intricately linked. But there is another element here. Science is dependent at the moment on a peer review system that has failed. As an experiment, it's hard to argue it works. I'm not going to go through all these points. This is just a list, a very long list, of problems with peer review. This is all based on evidence and scientific studies. Two things I will highlight. Peer review is not designed to detect fraud and is not very good at detecting gross misconduct or gross errors. That's quite surprising for a system that is very, very often sold as a quality control step. And the other thing that I want to highlight here is this last point. There was a study back in 2007 that looked at all of the data around peer review. Peer review here is very much meaning peer review of scientific articles. And in 2007, it was concluded that there wasn't enough evidence available to support the use of this system. Since 2007, there has been a lot of studies done, and if anything, I would say there is now enough evidence to support not using the current system we have. And one of the reasons this is really bad is a lot of things happen in private, and it's very opaque. So as a scientist, you have your manuscript and you submit that to a journal. That journal might decide they don't want to bother sending it out for peer review, so you'd have to submit to another journal. But maybe they do send it out for peer review and the reviewers don't like it. So you end up sending it to another journal. Maybe one of the peer reviewers likes it and the other two don't, so the journal rejects it. So you send it to another journal. Bit more lucky this time, 2 of the 3 reviewers like it, but for whatever reason the editor doesn't. So it goes to another journal and another one and another one. And it just keeps repeating over and over again until you get 3 reviewers who really like it and an editor who likes it. Now what's happened here is each of those ticks and crosses is an independent reviewer. It's a person reviewing that work. So instead of taking those reviews from journal 1 and using them in the system, they're just completely discarded. In fact, a lot of the times you won't even know they've happened. And there's a huge wasted effort here that is completely unsustainable and also not very transparent. It takes until, the example here is journal 9, until that peer review paper is made public. And even then, that peer review paper could still be wrong. You don't know that until you have a lot more feedback and ideas and people trying to build on the work. Only then can you really say if the paper is good or not, or reliable or not. That takes years in many cases, and it also takes many years to actually retract bad work. This whole process, just getting your work published, on average in the life sciences, takes about 6 months. There are cases I've seen, the longest I've seen, was 23 years, I think it was, from submitting the work to it being published, which is, I mean, you could have a child that is birthed at the start of that and is now an adult by the time you've had a paper published. And that's one paper. Not a great system, really. So where does academic culture come into play here? With the publishing system having such an oversized impact on academia, the way we judge researchers is through that system, almost exclusively. So impact factor is one of the ways to do that, and impact factor is the number of citations over the past 2 years that that articles published in a journal have received, basically. You can use that to say this journal is better than this other journal. Or people use it to say that. You can't actually, it doesn't really do that. So this is what it kind of looks like a little bit if you were to look at a small number of papers. And what this is showing you is that actually, if you look at individual papers, that distribution is very, very uneven. What you have is most papers actually not getting a huge number of citations, but the journal impact factor is pushed up by the small number of papers in that journal that do get a lot of citations to them. And when I say small number, I mean a really small number. There are also external factors that can have a really big impact on this. So this is just an example from The Lancet. The Lancet's impact factor in 2021 was 79.3, and then a year later it was 202.7. That would suggest that journal in a year has increased its quality by 255%, which obviously it didn't. But what happened was a huge number of people were citing COVID-related research. And it doesn't just have to be external factors. It can be a single paper that can do this. This is an insane example, I think. So this was a journal that had an impact factor of 2, which is relatively low, really. A single paper boosted that impact factor from 2 to 49. That tells you nothing. That number, that 49 number, tells you nothing about all of the other papers that were published in that time period for that journal. And yet it would suggest that that journal has now become vastly better, over 10 times better, well over 10 times better. When it hasn't, it's just one paper that had a lot of citations. This is a really, really bad metric to use, and yet it is so embedded within academic culture. And in addition to impact factor, we have this thing called H index. This is basically the number of papers you have that have a minimum number of citations. So I would have an H index of 12 if I had 12 publications that were each cited 12 times. If I had 11 publications and 10 of those were cited 10 times, I would have an H index of 10. All these kind of poor proxies lead to a really unhealthy culture in academia that actually damages trust. This is a prime example with the H index here. If you were to rank microbiology scientists based on their H index or their number of citations, this man comes out as being the best microbiologist in the world. Now, you probably recognize this name as someone who has been in the news quite a lot, especially over the COVID pandemic. This is a man who he's had a lot of work retracted, but is also facing a whole number of investigations around research misconduct, fraud, all that kind of stuff. This is probably the biggest case in the history of French science of misconduct. And yet, if you rely on all these poor proxies, they would tell you he's the world's best microbiologist. And what's really interesting is within the sort of academic culture, academic system, nobody wants to take responsibility. I was at a conference in 2024 and all the conversations I had with different stakeholders led to this slide. So we can blame publishers because publishers don't retract work quick enough. They profit from science, they exploit scientists, they're not doing enough to help readers. They're just money grabbing. We can also blame researchers I've given you a bunch of examples of researchers fabricating data. Researchers are not collaborative enough. They're too competitive. They don't do a very good job of explaining the science. They don't share things openly enough. They're not transparent. A really good example is when you ask for data or materials, a lot of researchers will not give you those things. You can blame institutions. Institutions don't bother themselves to investigate bad behaviour. They don't have any consequences, really, for bad behaviour from researchers. You can also blame the funders. The funders, you could argue, as the ones providing the money in the system, have the most power to stop badly behaved researchers. If a funder didn't fund researchers, there is a point where the institutions won't pick up that bill. And this is exactly what happens. All the different groups just blame each other. And this creates this circle of vicious, inescapable blame. Nothing moves forward. What we need to do instead is create a more collaborative, community-focused circle and bring all of these different stakeholders together to have very transparent, very honest discussions. That is how we can collectively improve the situation. And it does need that collective action. So trust in research, academic culture, and scientific publishing are three inextricably linked components. The problem is all of the movements to improve any one of those things are doing it on their own. Then there's nobody really working in these areas of overlap. Now, for me, the linchpin here is scientific publishing. If we can change publishing, that is the gateway to changing culture and improving trust. Because you can't improve trust if you don't change how the publishing system works. You can't change the culture if you don't move away from the metrics of publishing and look at other things. And that isn't going to happen without changing the publishing system. So I just want to zoom in on this aspect for the rest of this talk. My opinion is that preprints are the best way forward at the moment. That's because instead of going through this opaque process, which can take, as I said, about 6 months on average, but potentially much longer, preprints are available to the public within 48 hours. And I say 40 hours, even at the height of the pandemic, BioArchive, medRxiv, which are two big preprint servers, they were able to screen almost every preprint within 48 hours and make it public. So 48 hours versus 6 months is a big difference there. And when things are out in the public, that's where you get community feedback, you get your discussion, you can generate new ideas, you can build off of that work. It's a more efficient system. And these preprints, they are screened in a lot of servers, and that means we don't have to worry too much about pseudoscience. There are increasing efforts around tackling AI-generated papers, for example. The point is it's not a gatekeeping step, it's a protection step. So what is a preprint? A preprint is a complete manuscript openly shared online prior to journal-organized peer review. There are no costs to authors or readers. You might also know preprints as green open access. Preprints are citable. They've got a digital object identifier, so they're a permanent object. They can be peer reviewed, and they are shared when the authors believe their work is ready for sharing. What preprints are not is that they are not generally preliminary or early work. I've studied this, and it's really hard to find examples of early work type preprints. Authors just aren't posting them. Generally, preprints are not low quality or incomplete. Again, I've done research on this, and a lot of others have now as well. What all that data together shows is that preprints are comparable to the peer-reviewed literature. So if you don't trust a preprint, you shouldn't trust peer-reviewed literature either. They're also not rushed work. Preprints, because of the fact that they're so open, I think authors do take a bit more care when they post them. Preprints are also very often posted at the time of journal submission, so authors are happy to submit their work to the journal, so they're certainly not putting stuff out that is rushed or not ready for reading and sharing. The reason preprints are really good is they get us out of this tangled up publishing system we're in. Currently, dissemination, peer review, and creation prestige elements are all controlled by journals. They control the whole process. This motivates people, scientists, to delay sharing their work until they have a very complete story that's gone through multiple rounds of gatekeeping. And the incentive for journals is profit driven. That doesn't work when what we're actually doing is trying to advance society and human knowledge. Preprints break out of this by breaking this up. There's also a growing ecosystem of feedback around preprints. This is really good because it allows experimentation beyond just peer review. So we've got over 20 different feedback initiatives. These range from very minimalist freeform comments or social media posts, right up to what you would class as a journal-like peer review. eLife being the prime example of that kind of side. But within this, we've got things that are all trying to improve the peer review feedback process in different ways. Pre-review is a really great example. What pre-review are doing is they're really focused on increasing equity around transparent feedback. Pre-lights are really focused on early career researchers and actually not reviewing a work, but highlighting work that they think is really good. Review Commons is more focused on improving the efficiency of the review process for researchers and for journals. These different experiments allow us to do new things, allow us to see what does work, what doesn't work, and move towards improving publishing, improving culture. And this feedback goes way beyond just peer review. This is an example of a very famous bad preprint. This was posted and then I think within 48 hours it was actually withdrawn from the preprint server because it was found that it was just rubbish, basically. But what we found was that it got a huge amount of attention. You can see here at the time of this screenshot was taken, there was over 15,500 Twitter, because that was still a thing, comments about this preprint. There were 135 comments, and I should say preprints very rarely get any comments at all. These are really good indicators of trust because human nature, we like to talk more about the things that are bad than the good. So if something is getting this much attention, it's usually an indicator that something's wrong. And so you can see we've started to expand these markers of trust beyond just this one peer review step. This is just an image I put together of potentially what those markers of trust could become and could look like. But also this social media part in particular, it's not traditionally considered as peer review, and yet it is a peer review. It is a form of peer review. Preprints are also quite often posted after colleagues have seen that work and commented on it. That is also a form of peer review. We just often don't frame it as that, which we should. The other thing that a preprint is really good at is it gets us away from all those proxies I was talking about. It forces us to focus on the content of the work. So you've not got an impact factor, but what you do have is an open access article that you can read and access. And some preprint servers have this very brilliant little bit on it, which is the context part. By adding that context to the preprint, it switches things more towards the reader. It helps the reader understand the work, understand how much they can trust the work. And this really is the beginning of those trust markers. So we've got no impact factor. We've got no journal brand to rely on, no editorial gatekeeping, but we are still protecting against pseudoscience, and we're enabling an expansion of signals to help the readers understand that bit of work. And as science becomes more and more complex, even within my own field of immunology, it can be difficult to understand things that I don't do every day, things I'm not all that familiar with, because we do so many different techniques and science is becoming more and more interdisciplinary. Preprints are also a path to meaningful change. I've kind of said this a lot already, but they stimulate evolution and experimentation in just about every area of publishing and academia. This is just an example of a PhD CV that could be different now. Instead of just having papers on there, you're able to build a much bigger profile using preprints. You could do this through reviewing preprints, you can do this through highlighting them. So this would be pre-lights, for example. And there's actually a whole lot more you could add to this. Preprints are becoming more formally recognised. EMBO recognised preprints for their fellowships. Plan S very much considers preprints to be the equivalent to a peer-reviewed publication, if the preprint has been peer-reviewed. And then more recently, the Gates Foundation changed their policy to actually require preprints, and they encourage preprint peer review. That went into effect at the beginning of 2025. The thing here with the Gates Foundation is that they discontinued publishing fees, such as article processing charges, and this is currently being discussed by the NIH. So this is the system that I kind of really support, and I would propose we adopt. I call it the PITA system. So the publishing is done at the preprint stage. It's very much a community effort. We then have a layer of integrity and trust. So the integrity is very much on the author side of things, and that's about making a culture in academia where authors are encouraged, supported, and rewarded for more integrity and more rigorous science. The trust is more on the reader side of things. That's how can we instill trust in an individual article? How can we help readers know what is trustworthy research or not? And then at the end of that, we've got assessment. That's not just changing the assessment of the individual articles, but also researcher assessment. We should be rewarding open science practices, sharing, collaboration, but also things that aren't publishing related. So teaching, sitting on committees, mentorship. Importantly, this can all be scholar-led. We can move away from profiteering and perverse incentives, and we can bring it back in-house with academics. So that is basically an overview of what Rippling Ideas is as well, which is an organisation I've recently started. Hopefully it's going to become a non-profit and be much focused on advocacy kind of organisation. I would suggest signing up to the newsletter to keep up with what we're doing. You can follow us on Blue Sky, and we do have a website that expands on all those things I've talked about. Thank you.